science teachers about these, and they're like, yeah, like some of them are really adorable, and some of them are maybe not like teacher-student appropriate. Some of them are, but so I'm giving this to you as an opportunity to share some nerdy love, okay? So use this Valentine. You can keep it close to your heart, or I'm giving you the opportunity. If you forgot to get a Valentine for your Valentine, you now have one. I am. That's what I was saying, Gracie, is that some of them are appropriate, like teacher-student, right? Like, yeah. You know, some of them are, but not all of them are. And so I'm saying if you can use this as an opportunity if you forgot to go get a Valentine for your Valentine. All right. So, as with all wordplay, some of them are a little more of a stretch than others, but regardless, they're a nice, fun way to start our day. The other thing that I do want to tell you, because I feel like it's an important public service announcement, is that besides being Valentine's Day and being National Ferris Wheel Day, just learned that one, it is also, which, I mean, why in February, I'm not sure. Anyway, the other thing that it is National Organ Donor Day. Now, I don't know if y'all know what Organ Donor Day or what me and organ donor means, so I'm going to tell you because I believe in it and I think it's important, okay? You have the opportunity when you turn 18. I don't know if you can declare it when you get your license when you're 16. Can you? You can declare it when you're 14. Okay. So if you have your permit, when you go in to get your permit, they ask you, do you want to be an organ donor? Okay. And I am not trying to say, disregard some other personal beliefs that you have. So does that make sense? I am not, but I do want to let you know that your organs, if something would happen to you, can save up to 8 lives. Okay? And I just want to put that out there because it can make a big difference. So do it if you feel so inclined. And the other thing is that you need to let your parents know that you want to be an organ donor as well, right? You need to let the people know around you because it matters. So just, that's my little PSA for the morning because I think it's important. All right, we're going to do some science now. We're going to start with a capture question. We're also going to talk about climate. I would like for you to have your graphs out because I'm going to come around and peek at them while you answer this question. You also need your graphs to answer the question. Here it is. Looking at those graphs, looking at that graph data that you have, describe the climates of Cheyenne, San Francisco, and Des Moines. All right? All right. Looking at your graph data. Describe the climates or tell me something about Cheyenne, San Francisco, or Des Moines. You don't have to do all three. Let's get started. What you got? Go, Beth.
In San Francisco, the temperature is pretty mild. It usually stays in a range between 50 and 65.
Yeah. In San Francisco, the temperature is mild. And you also said it stays kind of in the same range, right? There's not a lot of variation. For sure. What else did you notice? Okay, thanks. Alexandra, what did you notice? Des Moines has warm summers. And can we extrapolate from that you don't have warm winters? What can you tell me about the winters? Are the winters pretty mild? Yeah, right? They're like colder, like a lot colder. Like we go from way up here, like upper 70s, right? And this is on average, and we all know that it can get really hot compared to that. And then on average, we're going like way down here, yeah. So I would say that we have warm summers, cold winters. And so then we have kind of a mild spring and mild fall, right? Because you have to have some sort of continuous curve, right? So we've got kind of extreme temps, don't we? right, David. Tell me more. What you got? Cheyenne is basically the same as Des Moines. What do you mean? What about it is the same? Cold winters, warm summers? Are they as cold and as warm? A little bit less cold down here and a little bit less warm, but they definitely have a temperature swing. They definitely have, how would we describe that? What do we have in Iowa that they don't have really in San Francisco? What was that? What were you pointing at?
Seasons.
Yeah! They don't have seasons in San Francisco, at least not in the same way that we do, right? When we think about cold, mild, warm, right? Like that kind of change. The Midwest and the upper, like I don't say Northwest, but kind of that central Western area, definitely they have seasons. There are not really seasons in the same way. Not the same change of seasons. And it's interesting. Some people prefer one over the other, right? I love seasons. I love having that change. But I know people that are like, oh my gosh, get me out of that. I need something plain and simple. Yeah.
So for like the precipitation.
Yes.
When San Francisco has a lot of rain, Iowa and Cheyenne has very little rain, and then it like switches. So when Des Moines and Cheyenne have a lot of rain,
there's kind of an oscillation, right? So even though San Francisco doesn't have seasons, as when we talk about that in terms of like temperature, they definitely have a rainy season, don't they? They definitely have a rainy season when we're having our dry, cold. It's still snowing, but it's not quite as wet as it is in the summer, right? So they've got rainy season, but they don't really have a temperature variation in terms of their season, for sure. So not the same change of seasons, but they definitely have a change in precip. Yeah. Let's see. Maddie, what else did you guys write down back there? What else did you observe? Sorry, Maddie King, go ahead. I didn't mean to be unclear there. I apologize. Any other pieces? Anybody else have any other pieces you want to add yet before we go in and dig into the questions? Okay. All right. We're going to come back to this in just a minute. I have on my list of things to do before we do the follow-up to start a demo experiment. So we're going to put this in our notes in just a minute. So I want to show you what we're doing. So I just have a little experimental demo up here that I'm going to show you what it looks like. So if you look up here, I've got two beakers, okay? One has, what does this look like? Sand, and one's got water, right? And then I've got these nice these are like little electronic thermometers. They're called temperature probes. And I'm sticking one in each of them. And they're just sitting here. They've been sitting here for, 25 minutes or so. How do you think the temps compare? They're probably about the same. So I got this set up and it's connected to my computer so that I can collect data. So I'm going to hit collect up here. It's going to start over and it's just going to start collecting data. Okay, so it looks like one's a little higher than the other, but they're about the same. Okay, life is fun. That's going to be a pretty boring experiment. But now I'm going to turn this light on. So this light is called a heat lamp because it puts out a lot of, anybody? Heat. Okay, so it's going to, and it's going to eventually cause the temperatures to change. I'm just going to let this keep going, and we're just going to collect this data and then look at it in a little bit. What's what? Yes, hold on. The blue one is temperature 1. Let me follow it here. So this one, that's the water. So the blue one is the water. That'll be easy to remember, right? And then the temperature 2 is the sand. So we're just going to let them sit there. And right now it's not going to be very exciting, but I think it's just going to keep taking data until I tell it to stop. So we'll just let it keep going. Okay. So it's just going to sit there for a while. What?
Wouldn't the water be getting more heat because it's like
Oh, true. Here, should I move it this way?
Yeah.
Does that feel better to you?
Yes.
Okay. Thank you for catching that. Awesome. Okay. Everybody good? So I'll just leave that on for a while. Boop. We're going to come back. So now on your green sheet or the sheet that you had, the one that went with your lab, we're going to answer some questions here quick and then we'll do some notes. It'll be great. So here we go. It says, hopefully you've done this, so this should be pretty straightforward. Rank the cities from the lowest to the highest winter temperature, December through February. So get us started here. I love ranking stuff. Ranking tells us a lot. Beth, you've told me way too many things already this morning, and I appreciate it, but I want to share the fun, share the love. Colin R., can you help us out with that? Number 1, rank the cities from lowest to highest winter temperatures.
Lowest as being the coldest.
Yeah, yep.
So Des Moines, and then Cheyenne, and then San Francisco.
Mm-hmm. I forgot how to spell Cheyenne all of a sudden. Cheye. Cheye. Oops, except I put the Y in already. And then the highest is San Fran. Except I really can't spell. SF? Yeah. I'll just say C. It's all good. We work together. We're a good team. It's all good. All right. So rank the cities from highest to lowest winter temperature. Des Moines is the coldest. Cheyenne's in the middle. San Fran is highest. And we said that Cheyenne is kind of closer to Des Moines in terms of its pattern, but it definitely is a little warmer than it is in Des Moines. All right. Number 2, rank the cities from lowest to highest range of temperatures during the entire year. Question or answer? Okay. I'm not going to call on you, not because I don't love you, because I want to share the fun. Miss Haley, what'd you say for that one? Lowest to highest range of temperatures. Lowest range is San Fran. And then Cheyenne. Cheyenne. I'm going to spell Cheyenne with no problem by the end of today. It's going to be great. And then highest then is Des Moines. Okay. Rank the cities from driest to wettest summers. Hayden, what you got for that one? Oh, well, you could do it right now, right? So driest to wettest summers. Do you need a copy of the precipitation graph? It looks like that. Driest to wettest summers. Okay. Okay. So I really, really like these questions for a couple of reasons. Number 1, it's good follow-up. Please stop talking. Thank you. It's good follow-up from just, what do you see? What do you see from a graph? Number 2, it makes you actually analyze the graph. And I think I mentioned this a couple days ago too, and I'm going to keep mentioning it probably until you're done with me for, your whole high school career. Being able to read a graph and to get information off of that graph, that's the science skill I want you to have, right? Okay? Do I expect that 30 years from now, you're going to be able to tell me that San Francisco has the lowest range of temperatures during the entire year compared to Cheyenne and Des Moines? Of course not. But if I walked up to you on the pinball and said, here's a graph, what can you tell me from the graph? Which I wouldn't do, but let's pretend, right? You should be able to tell me these things. Okay? What's that? I just pull one out of my pocket. I'll tell you what I'm doing. No, come on. You'd be like, Miss K. I'll be like, I don't have a graph. Don't worry. It's all good. All right. Really quickly, 1 minute with your table mates. Answer question 4 if you haven't already, or if you have, discuss it. Have a conversation.
Hi guys, number 4. Oh, that's so sweet. What do you guys think?
So answer that question with your table mates.
Nice.
All right. What did you say? Colin, you got an answer or is that a stretch? I'm still going to call on you either way. So, you're welcome. Go ahead.
You guys want to help?
No, you should be able to answer this, right? Just take a look. Based on this data, do you think the cities have the same climate?
I would say that they do have about the same climate considering that it's
Friends, the chatter that happens when someone else is talking in this class has got to stop. It's disrespectful, among other things, but let's just call that enough, okay? Whether it's me or one of you, if somebody has the floor, if somebody is talking, you need to at least be quiet. Listening's a great added bonus, but at least be quiet. Now, Colin, I want you to command the floor and answer the question. Based on this data, do you think that the cities have the same climate?
I would say not.
You say that they do not have the same climate?
No.
Okay, why do you say no?
For most of the answers, they're basically all the same besides the Moreland and San Fran, switch between highest and lowest. So
Okay.
it's pretty consistent throughout the year, temperature-wise and stuff like that.
The temperature is consistent in Des Moines?
No. It'll either get really cold or really hot. Where in Cheyenne, it's just average throughout.
In Cheyenne, the temperature doesn't change? Look at your graph, friend.
It does.
You're thinking of San Fran?
Yeah.
Yeah. And I'm not trying to pick on you. I want to make that very clear. But I do want you to be able to defend your answer. Okay? This is another one of those things, my friends. This is what I want you to get out of this class, is being able to look at data and answer a question, draw a conclusion based on data, so that you're not just talking out of your bum, but you're actually talking with authority. Does that make sense? Support your answers. So no, he says. No, why not? Let's look at the graphs, you guys. Come on. This is how we do it. If you look here, what does the temperature do in San Francisco? It stays the same. You're in California pretty much the entire year. It's the same temperature. Do you need a big parka? No, absolutely not. Do you need an umbrella? When?
When it's raining.
When it's raining in the winter, right? In our winter, in December, in January, you need a raincoat. But the temperature's not going to get crazy cold, and it's not going to get crazy hot either. It doesn't happen that way. Is it the same climate? What does climate mean? Maybe you don't know. We've been talking about this for 3 days. What does climate mean?
Over a long period of time.
Over a long period of time, what? The weather. What are you expecting? Long term, right? Long term. So let's write down our answers then, friends. Let's do it one more time. So no, we don't think they have the same climate. Why not? Because the temperature changes are not the same. Okay. Is that the only reason that we don't think they're the same? Take a look at that precipitation graph. Basic similarities in climate mean that they're going to have basically the same type of expectations throughout the year. Do you have the same expectations throughout the year in all of those places? Indeed, you do not. So then you need to articulate an answer. Talk to your table mates. Write something down right now. Don't get fussy with me. If we can do it, we don't have to go on and on and on with this. Come on. Why do you say they don't have the same climate? Write it down. Write it down.
Alright, so let's do it.
What do we say? Go, Haley. What'd you say?
They have different rainy seasons.
They have different rainy seasons. Absolutely. Absolutely. And if you put the temperature and the precipitation together, knowing that water freezes at 32 degrees, then any precipitation that we're going to have when the temperature is down here is going to be what? It's going to be snow, right? Does it snow in San Francisco? What's the temperature, friends? Does it ever get down to 32?
No.
No. So is it going to snow? No. Now, maybe one day, right? Like, but that would be weather. That would be like a fluke event. But in general, it's not. I mean, the average is between 52 and 64. Like, that's like maybe an hour in Iowa, right? And then it changes after that, right? That's crazy. All right. Different rainy seasons and different precipitation. Okay. All right. Please put your phone away, all the way away. I don't want to see it. Please put the green sheet, the climate stuff can kind of go to the side. Don't put it away all the way, but just kind of set it to the side and pull out that yellow sheet that I just handed to you so we can take some notes, some official notes on climate. Now, I will tell you, friends, so Tuesday was the day we had our snow day, and I put that reading up. Is this right? Yeah. I put the reading up. I said, read it, and then the pages weren't right. Remember? And then yesterday I was like, I'll fix it. And I did. And then when I reposted it, I apparently posted the wrong one. Nobody told me until 11:45 last night, so I didn't know. So I know that you didn't get those questions answered, at least not all of them, okay? The reading is now posted correctly. Please go do that sometime between now and, the end of the week, okay? So the real updated reading is up there. And friends, you've got to let me know. If I had known at 5 o'clock, I would have fixed it at 5:03, okay? I go to bed late, but I was asleep by 11:45. It's kind of a miracle, but it did happen. So please make sure you let me know if you're missing something. Any time would be helpful. All right, here we go. Climate notes. As with last unit, if you like to write on paper instead of on notes sheets, that's absolutely fine. Otherwise, we're right here on our yellow paper. Here we go. So climate, what is it? We've said this before, but we're going to say it again. Average weather patterns. Okay. Measured or observed over a long period of time. Do you remember what I told you a few days ago? The National Weather Service, as they're actually measuring climate, how long do they look? Do you remember? Was at least, remember? 30-year averages. Right? So climate definitely changes, but when they're looking at it, they're looking at 30 years of data at a time, okay? And not only is it measured over a long period of time, but we're talking about large regions. So we're not saying that the climate in Iowa City is going to be different from the climate in Des Moines. That's all kind of in the same region. So we're talking about long periods of time, and we're talking about large regions or areas of land. Okay. That's what climate is. There are two big factors that kind of dictate what an area's climate is going to be. Okay. So a climatologist, or you, now that we're talking about this, would be able to, without going somewhere and actually collecting data, because we've been doing it long enough, you can make some assumptions and you can make some good hypotheses just based on a few factors. First factor is temperature, okay? And there are some elements that go into that. The first one is latitude. Do you know what latitude means? What's that?
The distance marking south from the equator.
Yeah, awesome. Absolutely. So if we think about it, here's my Earth. The reason that latitude matters, do you know why latitude matters? Why is it colder the further north you go? Is it just inherently warmer there? Yeah.
The light from the sun received by the Earth is less farther north from, or like away from.
So there's a adjective in there that I didn't quite catch. So it has to do with the sun, right? It has to do with the light from the sun. So here's my sun, right? And the light from the sun is coming like this, and it's coming like this, and it's coming like this. So it's coming towards the Earth. So what is different at the equator than further north and south from the equator? It's farther from it? The temperature is warmer, yes. And I want to know why. What's different up here that makes it cooler up here and warmer at the equator? What is it about the light? What's that? Does anybody, you can, if you don't know, that's okay. I'm hoping that maybe somebody's heard this, that you've talked about it at some point. So the light here, as it comes from the sun, this right here is very direct light. Okay? The light that hits far to the north, way up here. So like if you look at my highlighter thing, do you see how it's coming in straight? But then if it's going to actually hit the surface here, do you see how it kind of has to bend over? Because the surface of the Earth here is kind of bent. And so in order to do that, it's got to spread out over more land area. Are you with me there? So the light is going to spread out over more area. So we have what we would call less direct or more indirect light. Same thing happens below the equator. Some people like to think that the southern hemisphere is somehow different from the northern hemisphere, and in this case, it is absolutely not. Again, it's spreading out over more land area, okay? It also has to travel through more atmosphere to get there, okay? All that gas that absorbs the heat, right? We get more indirect light. And as a result, that direct light provides more warmth, and thus we get warmer temperatures the closer you are to the equator, and cooler, again, either way that you go. Okay? It results in us having kind of three broad bands of climates. Close to the equator, we have what we would call the tropical climate. In kind of the middle here, we've got what we would call temperate. And at the very top and at the very bottom, anybody got a guess as to what that is? It starts with a P. The polar climates, yeah. Now, is latitude the only thing that makes a difference? Hint number one is that there's a whole sheet and a half left to do, right? Okay. Hint number two is actually kind of an interesting view of the three cities. You remember the three cities we've been talking about today? Cheyenne, Wyoming, San Francisco, and Des Moines. Now, we often think about those as being in very different locations, but if you look carefully at a map, and I don't want you to worry about the colors right now, but I want you to think about how latitude works. These three cities are at almost all exactly the same latitude. You see that? They're at almost exactly the same latitude. And so we know that the climate way over here in San Francisco does not match the climate in Des Moines, does not match the climate in Cheyenne. Cheyenne's the furthest north, and which one was the coldest? Which one was colder? Des Moines! We're the colder ones, even though they're a little bit further north. So the thing I want you to keep in mind with that is that latitude absolutely does matter, right? Go to northern Alaska, it's probably going to be colder than it is in Hawaii, right? Probably. But some of that has to do with latitude and some of that has to do with other stuff. All right. Speaking of other stuff, this one's pretty straightforward. Elevation. How high above sea level are we? How high? Oops. Or our distance above sea level. Okay. If we draw ourselves a nice big mountain, probably not surprised that where are you going to find the snow? At the base of the mountain, the foot of the mountain? No. You find it up high, right? Okay? The higher up you go, the higher the elevation, the lower the temperature. There's sea level. Okay? Why is that? You're closer to the sun, right? If you go up to the top of a mountain, you're closer to the sun, so shouldn't it be warmer?
It's hard to say.
What's different about being up there?
Less rush.
What's that?
Less atmosphere.
Less atmosphere. What is that? Why do we care? Absolutely. That's exactly right. Yeah. There's less air, less atmosphere. At high altitude. And thinner air does not hold heat as well. Or as I should say, effectively, not efficiently. Okay. All right. Keep cruising? Yes, please. Large bodies of water. What do large bodies of water do?
It's like most of the earth now.
It is, but how does it affect temperature on land? What's that? What about them? What do they do?
Well, when the ocean currents change, the temperature changes direction.
For sure. Yeah. So we've got, and actually that's going to be this next one down here, ocean currents. So we'll put a little check mark by that. Yep, we'll get there. Tell me about the large bodies of water in and of themselves. Do you know? We're doing this experiment right over here. Let's talk about it. Here it comes. What kind of large bodies of water am I talking about? I'm talking about like the Great Lakes. I'm talking about oceans. Okay. Talking about big things. Here's the thing that I want you to know. Well, actually, we're going to look at this demo first and see what has happened. So remember when we did this, the blue one was lower, wasn't it? But just by a little bit, and they were kind of even. They were staying consistent. Okay. So talk to me about what you see. Again, we're going back to data, right? What do you see here? Tell me one thing you notice. Raise your hand. Go, Elena.
The sand is warmer.
The sand is warmer, but the sand's always been warmer.
It's going faster rain.
But it's not only warmer, it's getting warmer
It's going at a faster rate.
faster. Does that make sense? It's getting warmer and warmer and warmer faster, whereas the water's getting warmer, but it's not getting warmer nearly as fast. If they were getting warmer at the same speed, then it would be nice parallel lines, right? Does that make sense? Okay, same slope, okay? But because the land is getting warmer slower, the land is getting warmer faster, it's got a higher slope, so these distances are getting bigger, okay? Is that making sense? Okay, we're going to write that down. I know we're getting close, but I need you to stay with me. The bell has not rung, and I need your brains on and with me right now until the end here, friends. Stay here. Okay? Why does this happen? Let me tell you. Water has what we call a high heat capacity. This is good science stuff here, okay? That means that it heats oh my gosh. Come on, there we go. And cools more slowly than land. So we say higher heat capacity than land. Okay? Now, I want you to underline the cools though. Hold on. I got 40 more seconds, friends. I want you to underline the cools. Because not only does it take the water longer to heat up, but it also takes the water longer to cool off as well. You with me there? Okay. Hold on to this. Make sure that you get those questions answered. Do them tonight if you would, please. Okay? Have a very happy Valentine's Day, whatever that means to you. Please take your Valentines with you and share them with those you love.